Hi everyone, so today we're going to be looking at halogenoalkanes. So halogenoalkanes are substituted alkanes and they are substituted by halogen functional group, and the name of the halogenoalkane will start with the halogen that is as the functional group. So if there is Cl, it's called so chloromethane, for example, chloroethane. If it contains fluoro, so it will be fluoromethane, fluoroethane, fluoropropane. If it contains Br, it will be bromo. If it contains I, it will be iodo. So for example, iodomethane. Now, if there is two of the functional group, if there's two chlorine, it will be dichloro. If there's three, it will be trichloro. 4, it will be tetrachloro. So you also need to count how many of them there are. For the sake of the formula, we're going to be looking at only one substitution. So just halogenoalkanes in general, and for not mentioning specifically if it's Cl, F, Br, or I, we'll be using X. So X is just showing that it's a halogen. So if it contains only one carbon, so one carbon, there's going to be one halogen. So the structural formula CH3X, molecular formula CH3X. If there's two carbon, so you'll have two carbon and filled up with hydrogen and then one halogen. And the structural formula will be CH3CH2X and then the molecular formula C2H5X. For free carbon, you're going to have, so free carbon and then the halogen CH3CH2CH2X, so CH3CH2CH2X. And then C3H7X. As you can see, you can recognize the alcohol here, just like the alcohol homologous series. So just instead of OH, you have X. This is for the 4-carbon halogenoalkane, and here, because you have CH2, 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 you can also write it like this. So CH2 3 times X. So from this, we can deduce the general formula. So again, you can see it's very similar to the alcohol homologous series. So CnH2n plus 1 X. So C4H. So 4 times 2, that's 8. 8 plus 1, 9. And then any halogens, it could be Cl or I or Br or anything. Now, when we are naming a halogenoalkane, we need to indicate the position where the halogen is situated. So you will need to label the carbon atoms, rather number the carbon atom, and you should end up with the name that produces the lowest possible number for the functional groups in the name. So here the functional group is the halogen. So here we are going to start numbering 1, 2, 3 instead of writing 1, 2, 3. So if we count like this, we'll end up with 3 chloropropane. So if we count like this, we'll end up with 1 chloropropane. They are basically the same compound, but the thing is that when we are naming, we need to have the lowest number possible associated to the functional group. So then this one is going to be wrong. So when we start numbering with here. Now, the number and the letters are separated by hyphen. Now, if there is 2 or more halogens, we're going to be using dichloro, trichloro, etc. And you will need to mention the position of each of the chlorine. Let's see a few examples. So here I'm going to start numbering. So 1, 2, 3, 4. Okay, so that's the longest chain. Or when I'm numbering like this, I can see that the chlorine is getting number 3 when it can easily get a lower number. So I know that my numbering has started the wrong way. So I will start again at 1, 2, 3, 4. So I know this is chlorobutane. So I'm just going to mention the position of the chlorine. So 2-chlorobutane. Now, if you have more than one type of side chain, so let's say you have chlorine and bromine together, so Br and Cl, you could have Br, Cl, and iodine together. We're going to list them in alphabetical order. So we'll have bromo first and then chloro. So this has 4 carbon, so it will be bromo, chloro, butane. Now I need to mention the position of the bromine and the position of the chlorine. So again, we're going to start numbering so that they end up with the lowest numbers. So 1, 2, 3, 4. So 1 chloro and then 2 bromo. Now the numbers and the words are separated by hyphen. So the name would be 2 bromo, 1 chloro, butane. Now, if there is more than one of the same alkyl side chain, so like I was telling you, if you have 2 chlorine, so then you will have to insert di, tri, tetra in front of the name. And you should also specify the location of the side chain. So, for example, here you have 1 chlorine and here. So you have 3 chlorine here. So this is going to be a trichloro. So you have 1, 2, 3, 4 carbon. So trichlorobutane. Be careful, this is not a methyl side chain. This is the chain which keeps on going. A side chain would be interrupting the flow of the chain. So here the flow of the chain keeps on going. You can see the carbon connected. So this is not a side chain, this is still in the main chain. So trichlorobutane, and you need to specify the position of the free chlorine. So you have 1 on chlorine number 1, and then you have 1 chlorine on carbon number 1 and 2 chlorine on the carbon number 2. So 1, 2, 2, trichlorobutane. Numbers are separated by commas. Numbers and letters are separated by hyphens. Now let's say you have this compound that you need to draw. So 2, 3 dibromo, so there's going to be 2 bromine. 3 methyl, so there's going to be 1 methyl side chain on a hexane chain. So the main chain is hexane, so 6 carbons. I'm going to number the carbons, and then I'm going to start putting the side chain. So 2, 3 dibromo. So there is 1 bromine on carbon number 2. There is another bromine on carbon number 3. 2, 3 dibromo. 3 methyl. So on carbon number 3, there's going to be a methyl side chain. So CH3. Here are the side chains. Now I can fill up with hydrogen. So here you have the compound. Now if you need to draw the structural formula, the condensed structural formula, you always start with the full displayed formula, and then from this you can get the structural formula. So you will have a CH3 here, so we'll start with the CH3, then CHBr, and then you have a CH3. I'll put the CH3 in brackets because it's a side chain, and then you have the Br, and then you have the CH2. So there's 1 CH2, 2 CH2, 3 CH2. So CH2 3 times, there's 2 times CH2 and then 1 CH3 here. So this is what the condensed structural formula would look like. Never try to attempt to write the structural formula directly from the name. Use the name, draw the full displayed formula, and then you move on to here.